All right, gang, Matt 6620 and 6999 putting up a short video here. But every time I say we have a short video, it turns out to be a long one. But I'll go ahead and file a disclaimer with you. Not a disclaimer, but a cautionary tale here. I have a house full of 11-year-old little girls running around. And you're probably going to hear a lot of, I've asked them to be quiet and for just maybe 30 minutes, but you know how that goes. So you're going to probably hear just complete chaos in the background. So do your best to look past that. Funny story. One of my Bailey's, her best friend Molly, she said, "What are you doing? Putting up a video?" And I said, "Yeah." And she said, "Is it a beauty video?" And I said, "Well, yeah, it is a beauty video. That's why I'm in it." And she said, "Well, I feel sorry for your audience." So, well, at least you don't have to look at me, okay? So, guys, what we're going to do here, I want to show a situation we run into with cronbachs alpha when we deal with dichotomous data. And the stuff that we've done previously in the video with just the alpha command from the psych package, we have to modify that slightly. Now, dichotomous data, what I think about here is we're running a test, and we let 0 be an incorrect response. And a lot of you are going to run into this when you use. Let me write that down before I talk. I'm not talented enough to speak and write. A lot of you are going to run into a situation when you use test on students where, especially multiple choice, where we have an incorrect or a correct response. Now, if we have a, let's say we're given partial credit, and the points are worth, say, 0 to 5 points, then you can run the reliability analysis just like we did in the previous videos, just using the alpha command from the psych package. But when you get into dichotomous data, coded zeros and ones, the traditional correlation, the Pearson correlation calculations don't work. And it's my understanding that the alpha package, or the alpha command from the psych package, uses Pearson correlation. Well, we have to make an adjustment on that, and I want to show you how we do that. First of all, there was a typo or a write-o, so thanks, Nat. You the man for pointing this out to me. I left out a negative sign, so a much more preferred calculation method that I use when I'm not dealing with the variance-covariance structure is to use this form here, see if I can remember it. Over, let's just call this our item score. Okay. And so each one of these parts needs to be defined for obvious reasons. K is just the number of items or questions. And this sigma, as I've put it here, this is just the item variances. And of course, this is just the score variance. Well, there goes that again. That's fun. So this is the total score variance for subjects. And this is completely totally clear. So I want to illustrate it nonetheless. So let's get out of this and take a look at a data set that a short, sweet one. We don't need a lot going on here. So let's say that we've got a situation here where we only have 5 students. We have 10 questions. And, again, obviously zeros represent that this first question missed the first question, but they got question 4 correct. So, again, zeros, they missed the question. 1, they got the question correct. So I'm assuming this is probably, well, I'm not assuming anything because I made this stuff up. One of the first things we want to do in working is to create these variances. And the first variance that we need is the total score. So I'm going to come up with something here to call score, and this is just going to be the sum of the responses. So for student number 1, I want to know not working that great. Okay, so student number 1 got 50%. And student 3 got 3 correct responses, and so on and so forth. So what I could do here is I could, someplace, and it doesn't really matter where, I'm going to go here, and I could take the standard deviation of these numbers. And, of course, then I can do this value squared. And I'm keeping those things separate for a reason. So the total score variance here would be equal to 5.2. Now what we got to do is we got to look at the variances across the items. So I'll tell you what, let me come in and insert a thing here. So what I want to do first of all is I want to do the standard deviation of the variances. Let me come in with one more. So if I go STDEV for these responses right here, and let's run that across all 10 questions. And then let's square these to get the variances. And then we're going to want to sum up these values. So we're summing the item variances. And we get 2.3 there. Okay? So, easy stuff here for people with, backgrounds in mathematics. So again, the total score variance was 5.2, and the sum of the item variances was 2.3. So let me get out of here and get back over here. And all right, gang. So our alpha, our measure of internal consistency, would be k, which is 10, over k minus 1, obviously 9. So 1 minus the sum of the item variances was 2.3. And the total score variance was 5.2. Now, Tanya, would you hand me the calculator? Thanks. Let's see what that turns out to be. So it looks like to me that our alpha here is 0.62. Now, we've only got 5 subjects. This is just for illustration reasons. Typically, again, we think about the cutoff about 0.7. So the internal consistency here, problematic. Something else that I want you to be aware of is let's look at question number 7. Question number 7 has 0 variance, and that's clearly going to be problematic. I don't even know how R is going to treat this because I haven't worked this problem. But I wanted to include that. I know SPSS will kick out that question and perform the item variance. I'm sorry, the cronbach alpha calculation on the other 9 questions. But we'll see what happens here. Now, what I want to do now is I want to get my data set ready to move into R. So I want to delete the student numbers, and I want to delete the scores, and I want to delete all this stuff down here that we used to make our calculations. So I'm going to save this on the desktop just as dichotomous alpha, DICH alpha. Okay? And that way I can go get it. All right. So let's get this out of the way. And let's bring up R. Now, let me show you, if we were going to enter this by hand, which is something that we have to do sometimes. You know what? I think I'm going to do that here. I think that's going to be beneficial, because we get so accustomed in this class to just okay, reopening will cause any change. Do you want to reopen? I don't need to. Okay. So let's get out of exit full. What I want here is I want to have 2 screens up so I don't have to go back and forth. Show you a way, and I gotta admit the illustration I'm doing here right now is for a couple of students who I know are going to be doing this here in a couple of months. So you might say, why is he doing that? There's a lot easier way. Well, I know the one situation is going to come up. All right, gang, one thing we could do if we wanted to enter our data just by hand, it's going to be so tempting to go across the rows. But remember, in cronbachs alpha, we're worried about the questions. So what I would do here is enter the questions, responses, and I think those are 5 for each, yeah. It's going to take a little bit of time, but trust me, there's someone watching this video that, or that will watch the video, hopefully, that needs to see this. Well, that didn't really save much time after all, does it? Well, that took longer. So just entering the questions. So 10101. That's actually the same as Q4. And Q6. Now, if you got if you're doing this with a large data set, it's going to be a lot easier to have 2 people obviously reading it to you. And this is really getting on my nerves. Okay, 10. All right, so we got our 10 questions. So you know what I would want to do now is put this in a data frame. and I'm just going to call that data. And so I got data frame, and so Q1, Q2, Q3, Q4. All right, now let's attach the data. I don't think it has to be attached, but it seems like it just seems like the right thing to do. All right, gang, let's get that out of the way and get back to R. Now, let me show you what's going to happen. Remember the cronbachs alpha that we have if we want to run an internal consistency on this dichotomously coded data. The cronbachs alpha, let me go ahead and get the psych package up. If we run alpha on our data, what's going to happen is we're going to get an inflated alpha. And you can see that our raw alpha here is 0.83. It's kind of handy to run this because it gives us more output than the other. Even though it's wrong, it's kind of interesting to look at. And we can again look like we did before. Wow, it's not giving the 95% confidence interval. And I don't understand why. But anyway, if we focus on the alpha when one is dropped, we can see that. Well, first of all, we can see the question 7 has been deleted. So apparently, it has dropped the zero variance question and calculated the alpha based on that question. But guys, we're not going to get 0.83 if we do that. I don't know. Let's go back and see what happens with that. I don't think. So let's get rid of Q7. It's going to be easy to do, right? We know what we're doing now. So scores equals sum. It's my understanding that it has to do with the way the correlation is. Well, that's not going to change. Let's see, variance of those numbers. It's 5.2, right? And let's go equal the variance of these numbers. And actually, the sum of the variances won't change. So equal sum because we 7.5. Oh, wait a minute. That's included the. So we want to change that to include only the scores. Yeah, and it's going to give us the same 2.3. So you can see that we still with the 5.2 and 2.3. I don't know what I was thinking. Deleting zeros is not going to change sums. Sums of variances and total score variance. So I was having a moment there. I would call it a blonde moment, but I don't have any hair, so can't call it that. So anyway, long story short, we don't get 0.83 as our cronbachs alpha. Okay? Well, let me show you how to take care of that. What you can do is you can install a package, and the package is LTM. And just like we do in other situations, go through the installation process, and then we're going to access the library. Okay. So. Now the cool thing about this, it's under the I'm pretty sure it's under the mass package, is there's a function that has cronbach alpha. And in this situation, we can see that we have 10 units, and we see that we get the alpha that we need. So guys, long story short, maybe went way out of route here to get this accomplished, but I just want you to know that when we have data that is dichotomously coded, which a lot of you will run into again on your master's theses. In fact, I know at least one group is running through that right now. Actually, two groups will go through this right now. You can't use the process that I tried to teach you in earlier videos with the Likert scale data. So, guys, keep this cronbach alpha on your radar when you have dichotomous data. So, guys, that's all I got. The girls have actually done pretty good. They haven't been too crazy loud. So I better get off here and count my blessings while I can. Take care.